Algebra 2, Chapter 7.3, Exercises 1 through 18. In this section of our Algebra 2 course, we're going to introduce some more complex methods of factoring, sum of cubes, difference of cubes, and factoring by grouping. You should, at this level of algebra, already have quite a bit of familiarity with these first three techniques we list: greatest common factor, quadratic, trinomial, and difference of squares. So we're just going to go through and use these techniques of factoring and get through this and learn what we can from it. So I'm going to, according to my tradition, work over the odd number of problems in this set and leave the even number of problems for the viewer. Factor the polynomial or identify it as irreducible. We have problem 1 here, x cubed plus x squared minus 12x. The first thing we do in looking at a polynomial to factor is search it for a greatest common factor. In this case, we have an x common to each of these three terms. So what I'm going to do is rewrite this polynomial as x times quantity what times x equals x cubed, that's going to be x squared, and what times x equals x squared, that's going to be plus x, and finally we're going to have minus 12. And so now what we have is x times what we hope to be a quadratic trinomial, and I usually just set up my parentheses like this, and one like this, x squared plus x minus 12, should be, with the coefficient of x squared being 1, a pretty simple one if this is indeed factorable. I think it is. The factors of x squared are going to be x and x, and then we look at our final term. We have minus 12, meaning that we're going to have a negative times a positive to get 12. And so now we ask ourselves the question, what two numbers which when multiplied together equal negative 12 add together to equal 1, as in 1x? Well, the two numbers involved are going to be 3 and 4, because 3 and 4 are just 1 apart, and we have plus 1, and since we have plus 1, our 4 is going to have to be associated with the binomial on the right, and then we have x minus 3. And so if we multiply these three factors together, we're going to come back with our original expression, meaning that this is our correct solution. So we'll just go on to the next odd number problem, which is 3. Now in this case we have a cubic expression, a cubic binomial. And for cubic binomials, there's a technique called a difference of cubes or a sum of cubes. In this case we have a difference of cubes, and I'm going to go ahead and write out what that form for difference of cubes is. If we have a cubed minus b cubed, that can be factored to be quantity a minus b times quantity a squared plus ab plus b squared. And this is going to be, this one on the right is going to be irreducible. So we can write for this x cubed minus 125, we're going to have, it would be like a is equal to x, and b is going to be equal to the cube root of 125, and the cube root of 125, I hope you recognize, is 5. And so we can write this cubic polynomial as, I'm going to put an equal sign here, we're going to have a minus b, in this case x minus 5, times, we have x squared plus ab, well, b is going to be 5, plus b squared, and b being 5, b squared is 25. So that's using the difference of cube to factor this cubic binomial. The next algebra problem is 5. We have 8x cubed plus 125, and this term 8x cubed, if we can find the cube root of 8x cubed, we will have a value of a, well, I haven't written the form here, it's a different form. If we have a cubed, this is going to be a sum of cubes, a cubed plus b cubed is equal to quantity a plus b times quantity a squared minus ab plus b squared. So that's what we're going to use. Okay, back to our problem at hand. The cube root of 8x cubed, cube root of 8 is 2, and cube root of x cubed is x. And then the cube root of 125, as we found out doing problem 3, is 5. And so now, using our sum of cubes form, we can rewrite this expression as, we will have a plus b, and a is going to be equal to 2x, b is going to be equal to 5. So we're going to have 2x, quantity 2x plus 5 times, we're going to have a squared, I'm just going to do a little side problem, a squared is going to be equal to 2x squared, which is equal to 4x squared. So we have 4x squared, which is a squared, minus ab, well, a is going to be 2x, and b is 5, and multiplying these two together we get 10x. And finally we have plus b squared, and b is 5, and 5 squared is 25. So this is going to be our factoring using a sum of cubes in this case. Next algebra problem, 7. Now I would first be tempted in problem 7 to look for a greatest common factor, and if we take a greatest common factor out, let's say we take 2 out of this expression, we're going to have 2 times, that's going to be 108x plus 32, that's 8x, 108x cubed plus 32, and if we factor another 2 out, we're going to have we'll have 2 times 2 is 4, and half of 108 is 54. Plus 16. And we can factor another 2 out of here and get 8 times 27 that's x, 27x cubed plus 8. And so we have that in place, but I think we would have been able to do that even with the original. But that's the principle. Use greatest common factor first. And for this 27x cubed plus 8, this will be a sum of cubes, because the cube root of 27x cubed is equal to 3x, and similarly the cube root of 8 is equal to 2. So now we can go ahead and apply a sum of cubes. So I'm putting an equal sign here. We're going to have 8, which is we commonly factored out. Then we're going to have a plus b, and a is equal to 3x, b is equal to 2, so we have 8 times 3x plus 2, and then we're going to have a squared, and since a is 3x, a squared is going to be 9x squared, and we're going to have minus ab. Well, a is 3x, b is 2, so we're going to have minus 6x, and finally we're going to have plus b squared, which is 2 squared, which is 4. So this will be our factored form of problem number 7. Next. Now here we have a possible difference of cubes. We have 10x cubed minus 80, and a greatest common factor here is going to be 10, so I'm going to take 10 out here, and 10 times x cubed minus 8. In this case, a is going to be equal to our cube root of x cubed, which is equal to x, and b, our b is going to be equal to cube root of 8, which is 2. And so what we have here is our factoring is going to be 10 times a minus b. Well, that's going to be x minus 2 times quantity a squared, which is x squared, and we're going to have plus ab, which is 2x, and finally we're going to have plus b squared, and 2 squared is 4. So this is going to be our factoring for problem 9. I just a little earlier forgot to mention that in looking at the book solutions, should you be so fortunate as to have a teacher's edition, I noticed that the teacher's edition and the solution for problem 8 in that edition, the edition I have anyway, is incorrect. So just watch out for that. Just be careful about sum of cubes or difference of cubes. Okay, next to the next odd number problem, we have 11, and for this we look for a greatest common factor. In this case we have x common to all three terms. We take out this x, so that's going to be x times quantity x squared plus 10x plus 16, and then we have a quadratic trinomial we will attempt to factor, and the factors of x squared are going to be x and x. Our middle term is positive and our final term is positive, meaning that we're going to need a positive and a positive for each of these two linear binomials. And so now we ask that crucial question, what two numbers that when multiplied together equal 16 add together equal 10? Well, those are going to be 2 and 8. And so now we have the complete factoring for problem 11. Now, the next section here, 13 through 18, is to factor the polynomial by grouping. So this is a more advanced technique that you're probably not familiar with at this time. And not all cubic polynomials are candidates for factoring by grouping. What you have to have is the same ratio of coefficients going on here. And I think I'm going to demonstrate this as I go. What I'm going to do is we're going to group these two sets of polynomials and look for common factors to each of them, and really looking for the number. Well, what are the common factors to this first group? Well, I hope you notice that we're going to have x squared as a common factor. And then if we pull an x squared out of this first grouped pair, we're going to be left with x plus 8. And then we have plus, and what we try to do is see if in this next set we also have an x plus 8, but between 6x and 48, what is our greatest common factor between those two? It's going to be 6. So 6 times what equals x? 6x, well, it's going to be x. We'll have x plus 8. And so now we have two groups with a common factor of x plus 8. And so we can rewrite this expression up here as quantity x plus 8 times quantity x squared plus 6. And then you look and see if there's any more factoring that can be done in this second factor, this quadratic binomial x squared plus 6, but that x squared plus 6 is not factorable, meaning that this will be our answer for problem number 13. Next odd number problem. Okay, we look for the proportions. We have 8x to the fourth power plus 8x cubed plus 27x plus 27. And so in this first group, again we're going to take these two groups. In this first group, our common factor is going to be 8x cubed. So what times 8x cubed equals x to the 4th power? That's going to be x. And then what times 8x cubed equals 8x cubed? That's going to be 1. And so we put plus here. And now out of the second group, what is our greatest common factor? That's going to be 27. And 27 times what equals 27x? That's going to be x. So we're going to also have x plus 1. And so now we can rewrite this expression in factored form as quantity x plus 1 times quantity 8x cubed plus 27. Now, in this 8x cubed plus 27, do you recognize something here? Well, you should. You should recognize this as a sum of cubes. And so, in the sum of cubes, you might recall if you have a cubed plus b cubed, that's going to be equal to quantity a plus b times quantity a squared minus ab plus b squared. So let's go ahead. In this case, a is going to be equal to the cube root of 8x cubed, which is equal to 2x, and b is equal to the cube root of 27, which is equal to 3. And so now we can use this information to rewrite the expression as quantity x plus 1. And then we're going to have, we have a plus b, quantity a plus b, which is going to be 2x plus 3. And then we're going to have times quantity a squared, which is going to be 4x squared. And it's going to be minus ab, which is going to be 2x times 3, or 6x. And finally, plus b squared, and b being 3, 3 squared is 9. And when we do a difference or sum of cubes, this last quadratic trinomial here is irreducible. So this is going to be our fully factored form for problem 15. Next we have problem 17. And we have x cubed plus 2x squared plus 3x plus 6. And go ahead and set these off as groups. And out of the first group, what is our common factor? That's going to be x squared. So we have x squared times quantity x plus 2 plus, in the second group, what is our greatest common factor? 3. And we're going to have 3 times quantity x plus 2. And so between these two factor groups we have a common factor of quantity x plus 2. So we have x plus 2 times quantity x squared plus 3. And this quantity x squared plus 3 is irreducible, so this is going to be our worked out problem 17. Basically, you have to have the same relative proportionality. Not all cubic polynomials are going to be factorable by grouping, like these are in this set. Well, that's it. I hope this has been helpful to you. Good luck, and thanks for viewing.